In part 1, we reset the drive to factory default and reset the soft PLC to factory default. We then set up the motor parameters, built a Pump Genius for our specific drive, and downloaded it to the drive. In this video, we'll configure the parameters for the Pump Genius. The good news is the Pump Genius is very capable. The bad news is that means there's a lot of parameters to configure. But the good news is WLP has a Pump Genius wizard that walks us through it one little step at a time. Now, if you haven't done so already, double-click over here to bring up that wizard. We see this is a Simplex version of the Pump Genius. That is, we're only using one motor and pump. Next. First, we set up the local and remote speed reference and control inputs. In the PID Quick Start videos, we used remote only, so we'll do that here too. In remote mode, when we're running the Pump Genius, the soft PLC will control the speed reference. We don't care about forward and reverse, so I'll set that to not used, and run stop will be controlled by digital input. Next dialog. We use the default digital input 1 to control run stop, which is what we did in the PID Quick Start video. We also use digital input 2 to control the auto manual mode of PID, but the Pump Genius doesn't allow that. You have to use digital input 3. We changed that wire in our test set in part 1. We didn't use any other inputs, and we didn't use any outputs in the PID Quick Start videos. You would normally set the outputs to drive a process running light, a fault beacon, or one of the fault conditions. We'll just turn those off for now. Next. Here we set up our ramp times. You want to keep those as short as reasonable so they don't interfere with PID's ability to do its thing. In the Quick Start videos, we used 0.2 seconds, which was something you would probably never use. But we'll do that here to keep things as similar as possible to those Quick Start videos. Also, as we explained in the PID Quick Start videos, these min and max values are really important. Mostly, make sure the min speed is a little above where the pump stops pumping, and the max speed is the motor speed that maxes out your sensor. This is what we used in the PID Quick Start videos. You can watch those videos to find out why. Next. The process variable is coming in on Analogue Input 1. Next. Tell Analogue Input 1 that he's the process variable, we're using a 0 to 10 volt sensor, our units are PSI, and we'll use 1 decimal point. Now don't forget to make sure that the dip switch on the I/O module is set to volts. This is where you set up the analog input. We don't need an offset, gain of 1 is good, and I always like to add a little filtering. Just keep it small or it'll make PID less responsive. These go with the min and max speeds we set back here. So when the motor runs from this min to max speed, our sensor runs from 0 to 15 psi. Notice this uses our engineering units. Now this is what PID uses to calibrate all of its calculations, so make sure you get this right. Again, see the PID Quick Start video for more information on that. Next. This is a forward or direct PID loop. That is, the pressure goes up when the motor speed goes up. Reverse would be like a cooling system, where the process variable, the temperature, goes down when the motor speed goes up. Next. Do we want the Pump Genius to always run automatically, control it manually, or use a digital input to switch between the two? We used a digital input to switch between the automatic and manual modes in the PID Quick Start, so that's what we're doing here. So this just says, use the digital input we assigned in parameter 265 back in the second dialog to control this switch. So digital input 3 will decide if we send the PID result or a value we manually set out to the drive. This is the bumpless mode we talked about in the PID Quick Start. We'll leave that off again, but in most applications, you'll usually want to enable it. Check out the bumpless videos to learn more about that. We'll use the Pump Genius default coefficients, which are a little different from what we used in the previous PID Quick Start videos. And we'll start the manual set point at 0 Hz so we aren't surprised when we turn this thing on. Next. We want the set point to be controlled by the drive's keypad, which can also be controlled by a network write. Next. We want to use the same 6 psi set point as the Quick Start. Again, that's in engineering units. By the way, if you mess up on any of these dialogues, there's a handy default button down here which will reset that dialog. I've used that more than once. And hit Next. We'll skip sleep mode for this demo. There's a whole separate video on that if you want to learn more. It's great for things like tank filling applications or anytime you want PID to sleep until there's demand. Since we aren't using that, we skip the sleep mode configuration dialogues and go from this dialog 11 all the way to dialog 14, where we can add pipe charging. If enabled, it'll turn the motor on like this for this much time to pre-fill the pipes before reverting to PID control. This is common in irrigation systems or if you just need to prime your system. You can also specify a maximum amount of amps allowed during pipe charging so you don't overload the system during this time. We won't be doing pipe charging in this demo, so we hit Next. Here we can set up our high and low level alarms. Normally, you'd want to set the high alarm below the pipe's burst pressure and the low alarm to whatever your system needs. You'll get an alarm when either happens, and after the time specified, you'll get a fault and the drive will shut down. For this demo, we'll disable the faults by leaving our time set to 0. And we'll make sure the alarms are beyond our 0 to 15 psi range just to keep things simple. Next. You can set up a dry pump alarm. That is, if the motor speed revs up or the torque drops because there's no load, issue an alarm, and after so many seconds, issue a fault and shut the system down. We'll disable that by setting these beyond the min and max speeds we set in the third dialog and leaving the fault time set at 0. You can also have an external sensor, maybe something that's detecting low suction, for example, and if that sensor, which is normally closed, opens, then you get an alarm and sometime later get a fault that shuts the system down. We'll leave that disabled. You can also do that with an analog input. We'll skip that too, which allows us to skip over a few more dialogues. You can derag the pump on startup, a digital input, or if clogging is detected. Deragging automatically reverses the motor to clean off the impeller. That's primarily for wastewater applications. We'll leave that off. We want the set point on the first line of the display, the process variable on the second line, and the current in amps on the last line. And we're done configuring the Pump Genius parameters. I like to drag to select this parameter summary, copy it, and paste it into a document so I have a written record of all the parameter values. You can also print it to all the usual places, including a PDF. Hit Finish, and it asks you if you want to send the values to the drive. Sure. And of course, remember to save the project so you don't lose everything you've done. Okay, in part 1, we put the Pump Genius app in the drive, and in this part, we configured the parameters. The drive is ready to go. Join me in part 3, where we'll do a live demo of the Pump Genius in operation. Meanwhile, click here to learn more about the WEG CFW500 drive. Click here to learn about Automation Direct's free award-winning support options, and click here to subscribe to our YouTube channel to be notified when we publish more videos like this one.